Good afternoon, my name is Sinis Ancuyos and I will discuss about aggregates. What is aggregate? Aggregate is a material used in building and construction that is mixed with cement, bitumen, lime, gypsum, or another adhesive to form concrete or mortar. The aggregate provides the finished product with volume, stability, resistance to wear and erosion, and other desired physical properties. Aggregates make up 60 to 80% of the concrete mix. They give concrete compressive strength and bulk. Furthermore, concrete mixes are chosen for their durability, strength, workability, and ability to accept finishes. Aggregates for a good concrete mix must be clean, hard, and strong particles free of absorbed chemicals or coatings of clay and other fine materials that could cause concrete deterioration. Aggregates are divided into two types, either fine aggregates or coarse aggregates. Fine aggregates are used to create thin concrete slabs or other structural members with a smooth surface. Coarse aggregates, on the other hand, are used for more massive members. Now, let's proceed to properties of aggregates. The first one is its composition. Aggregates containing materials that can react with alkalis in cement, causing excessive expansion, cracking, and deterioration of the concrete mix should never be used. As a result, aggregates must be tested to determine whether such constituents are present. Aggregates that are commonly used include sand, crushed or broken stone, gravel or pebbles, broken blast furnace slag, boiler ashes or clinkers, burned shale, and burned clay. Sand, crushed stone, or crushed slag screenings are the most common types of fine aggregates. Coarse aggregates, however, consist of gravel or pebbles, broken stone fragments, slag, and other coarse materials. Second, the size and shape of the aggregate particles have significant impact on the amount of cement required in a concrete mix, and as a result, the overall economy of concrete. Fine aggregates have a diameter of less than 9.55 mm, whereas coarse aggregates have a typical diameter between 9.55 mm and 37.5 mm. Third is its surface texture. The development of hard bond strength between aggregate particles and cement paste is determined by the aggregate particle's surface texture, roughness, and porosity. Maximum bond strength develops when the surface is rough but porous. Aggregate surface texture can be smooth or rough. While a smooth surface improves workability, a rougher surface creates a stronger bond between the paste and the aggregate, resulting in greater strength. Specific gravity is when the weight of oven-dried aggregates maintained for 24 hours at temperatures ranging from 100 to 110 degrees Celsius to the weight of an equal volume of water displaced by saturated dry surface aggregates. Bulk density is defined as the weight of aggregate required to fill a unit volume container, or the mass of the aggregate per unit volume. It also determines the type of concrete for which it can be used to assess aggregate's quality. It is usually expressed in kilograms per liter. The sixth one, voids, which are known as the gaps between the aggregate particles. The volume of void is equal to the difference between the aggregate mass gross volume and the volume occupied by the particles alone. Next is porosity and absorption. Pores are the minute holes formed in rocks by air bubbles during the solidification of molten magma. Porous rocks are those that have pores in them. Water absorption can be defined as the difference in weight between very dry aggregates and saturated aggregates under surface dry conditions. The fineness modulus is commonly used to determine how coarse or fine an aggregate is. A higher fineness modulus value indicates a coarser aggregate, while a lower fineness modulus value in the case of finer aggregate. The ninth property in aggregates are deleterious materials, which are also known as prohibited materials. Aggregates should not contain any harmful materials in such quantities that they compromise the strength and durability of the concrete. Crushing value. The aggregate's crushing value is a relative measure of an aggregate's resistance to crushing under gradually applied compressive load. It is defined as the percentage by weight of crushed material obtained when test aggregates are subjected to a specified load under standardized conditions. The aggregate impacts value gives a relative measure of the resistance of an aggregate to sudden shock or impact. Toughness is the ability of a material to withstand a sudden impact. Lastly, abrasion value of aggregates. The abrasion value gives a relative measure of resistance of an aggregate to wear when it is rotated in a cylinder along with some abrasive charge. In other words, it is the value that determines aggregate toughness and abrasion resistance. It includes aggregate properties such as crushing value, degradation, and disintegration. ASTM was originally known as the American Society of the International Association for Testing and Materials when it was created in 1898 by Pennsylvania railroad engineers and scientists. Its goal was to address and prevent the industry's frequent rail breaks by developing standards that would ensure higher quality rail products. Today, it is known as ASDM International. ASTM is still headquartered in Pennsylvania, but it also has offices in Belgium, Canada, China, and Mexico, as well as one in Washington, D.C. ASTM has come a long way since creating steel standards for the railroad industry. Today, ASTM develops and publishes technical standards for a variety of industries with the goal of improving performance and safety across a wide range of products, materials, systems, and services. Thousands of ASTM standards are followed all over the world, each with its own unique number. Each standard falls into a variety of categories which include standard specification, standard test method, standard practice guide, standard classification, and terminology standard. This is a list of ASTM International standard designations. Standard designations typically include a letter prefix followed by a sequentially assigned number. This can be followed by a dash and the last two digits of the year the standard was implemented. The following subjects are represented by prefix letters: A for iron and steel materials, B for non-ferrous metal materials, C for ceramic, concrete, and masonry materials, D for miscellaneous materials, E for miscellaneous subjects, F for materials for specific applications, G for corrosion, deterioration, and degradation of materials. What is AASHTO? The American Association of State Highway and Transportation Officials is a nonpartisan, nonprofit organization that represents highway and transportation departments from all 50 states, the District of Columbia, and Puerto Rico. It includes all modes of transportation such as air, highways, public transportation, active transportation, rail, and water. Its primary goals are to promote the development, operation, and maintenance of a national transportation system that is integrated, to educate the public and key decision makers about the critical role transportation plays in ensuring our nation's good quality of life and sound economy, acts as a liaison between state transportation departments and the federal government. These are the sources I used for my report. Thank you for listening.